Hello everybody, in this video we are talking about solving quadratic equations, and we still do a little bit of factoring. For this lesson you will need factoring, equation solving skills, quadratic function knowledge, and of course you are going to be dealing with a little bit of radicals. Alright, so guys, list all the characteristics of a quadratic. Alright, let's go ahead and list them. So we know about the domain, sorry y'all, having trouble with my pen. Domain. What else do we know? Range. What else do we know? The intercepts. X and Y. And what else did I call them? Well, today, if I didn't say this already, surely today, we're going to be calling them a special word, zero. Alright? The max, min, vertex, and axis of symmetry. When the quadratic function transforms, which of the characteristics stay the same? The answer is domain will stay the same, which we know is going to be from negative infinity to positive infinity. It doesn't matter if you write x squared, it doesn't matter if you write x squared plus 4x plus 1,000, doesn't matter how you write it. The characteristic that always stays the same is the domain. What changes a lot of times when you put in these quadratic functions in the decimals is going to be your range that changes the most. Of course, your intercepts will change. In some cases, you may not even have a x-intercept for sure. So your range changes, your intercepts, your basically all the other characteristics. When you're really dealing with the quadratic. And also, that's pretty much just it. Just that. Alright guys, now I want to, talk to you about decimals, because in this lesson, one of the things that we're going to be doing, of course, is using decimals to help us check our work when we're solving the equations graphically. Alright? So let's go ahead and do it. So, what we know is about this graph, when we think of those intercepts, the x-intercept, x, of course, that it has two x-intercepts, which are 0 and 4. So essentially, when we think of the graph, all this is saying that the graph will have that this function will have two answers when we solve for x. And you see that later on in this lesson. So it got two solutions. But sometimes in a quadratic function, you don't always have two solutions. Sometimes you have the one. And what this is saying that, it touches the x-axis, which is, you could still call a intercept because, where it's touching or whatnot. So you could still say that in a way. Notice I say in a way, because although it's not crossing the x-axis, it still touches it. So you can still call it, because that's where they both meet up at. But what this graph is telling you, that you have one answer. This function has one answer. But sometimes, and most of us don't want this situation because it makes it a little bit harder on us, is when you don't have a real number solution. You have an imaginary solution. Geez, Mr. Howard, what is that? So, sorry about that. So let's explain this a little bit further then. So, what I mean by having an imaginary solution, I mean it's not real. And this goes back to radicals. So let me ask you a question. Why would I bring a radical involved in dealing with a quadratic? Why would I do that? Well, let's go ahead and talk about it right now. So, radicals. So, believe it or not, square, which means x to the power 2, its opposite, its inverse, is the square root. Like how addition is opposite of subtraction, multiplication is the opposite of division. But one thing that we're going to use in this class, let's try to be more math professionally correct. So the addition inverse, the additive inverse, of course, is subtraction. The multiplicative inverse is division. So the inverse of a square is square root. Geez, Michelle, where are you going with this? So let's do it. So we know 5 squared is equal to 25, right? Well, the square root of 25 is 5 because 5 times 5. And you could go back to that. Or 5 squared. See how the radical goes back to the exponent. The exponent goes back to the radical. It's one another. But in a way, so moving on from that and still talking about radicals, you're going to learn, well, have learned by now, that a square root, going back to the complex numbers, And when I'm talking about complex number, you have one real number plus an imaginary number. Geez, Mr. Howard, what's an imaginary number? I forgot. Well, guess what? It's okay, because Miss Howard will take care of you. So, what an imaginary number is a square root that has a negative number in there. So look, the square root of 3 cannot be negative. It's not allowed to be. Let me give you even a better example. So suppose if I was simplifying the square root of 4, but it's negative. I can't have that. I can't have that at all. So the negative number, you rewrite it as I, but that 4, the square root of 4 is what? 2. Becomes 2i. At some point, you guys should have had some practice with simplifying radicals. So you should have had some knowledge of even radical operation. But anyway, I could discuss that later if we need to. But look, you can't have a negative number in the square root, so it's not real. Ain't no such thing as a negative square root. The reason why this goes on is because you look at the graph of this function, and that's why it's imperative to pay attention to the characteristics of these functions. So here, a square root function looks like this. A half slice of the quadratic. So look, this particular characteristic of this function, the domain has to be 0 to infinity. It has to be greater than 0. It can't be less than, because look, you have all this space here, it doesn't exist. So that's a good mathematical reason why you can have a negative number in the square root. Because when you think of the domain, you think of all the x values. So of course, when we, solve or whatnot, we have to have all that. And that's for, just dealing with the radicals itself. Again, that's only for the radicals because of the basic description of the quadratic. All right, and we could discuss radical functions later. We really got to get into the lesson. So again, this explains really why a negative number in the radicals cannot happen. All right, so now let's go ahead and get to some factoring, because the factoring is pretty much key to this. So by now, you should know that the prime factors of C being 13, we have to figure out what two factors times 13 gives me 14 when I add them together. So of course we said 1 and 13 gives me 13 when I multiply. And then when I use those same two factors to find the sum of 14, I get it. All right. Factor out accordingly. And then I checked my work. I applied the for method to check my work. Okay. Alright, guys. Let's go ahead and get to our work. Now, I'm going to do something unique here. Usually I show you all the steps, but we're going to go from top and bottom, and we're going to work everything in the middle. That's what our answer should be. So let's go see the work behind it. So look, guys, we're going to do my favorite method, the swing method. Alright, so let's do it. So of course, you multiply 2 and 5, 2 and 5. 2 times 5 is 10. Alright, and then you rewrite it as d squared plus 7d plus 10. You do your rewrite. Now, from there, ask yourself a question. What two numbers give me 10, which we already did, 2 and 5, because 2 plus 5 also give me 7. Always be worried about that middle term here. Alright? So let's do it. So we get d plus 2, d plus 5. Alright? We're not quite done yet, because now the 2 that we had in front originally, you put right here, you put right here. 2 divided by 2 is what? Because you keep that whole number, you guys are cool here. But then 5 divided by 2 does not give you a whole number. So guess what? Swing it. 2d plus 5. And that is how we get this guy. Just like that. Alright. You guys should know how I factor this. So I want you to actually do that yourself. I'm not wasting time on it. That's something that you would do. Remember, in the videos, any problem that I told you to do, you need to do it. Do not, watch the video and think that this is now so part of the grade. This is the most important piece. The stuff that I'm telling you to do. These are more so important than the Kahoots, actually. These are worth more points. Alright, guys, let's go ahead and talk about completing the square. Ooh, not my favorite method. Because it's a bit confusing and everything of it. You guys going to bounce find out. So, in some cases, things may look like they cannot be factored. But, the good news is, they can be factored. But you got to complete the square to do it. So, this technique focuses on two things. So, taking this middle term and going to work on it. So what you're going to do, you take b, the b term, and you simply divide it by 2. 24 divided by 2. And then, of course, you square it. Alright? But in this parentheses, when we rewrite it, like so. You will notice something here. They have the same exponent, and then they both have a m out. So look, in this particular case, you could write this in a factor form of m plus 12, because 24 divided by 2. And then you just square all of that, because again, that's part of completing the square. So doing it just like that. Now, then the rest of, what about 19? Well, believe it or not, you leave 19 alone. So you go plus 19 minus, now you got minus this guy, minus the 144. All right, you're almost done. 19 plus 144, or 19 minus 144. I don't know why I'm thinking plus. Minus 125. And again, on this side, it's always going to be minus. This is always going to be minus. And from this side, you do not square that. Square what's in the inside of the original parentheses. All right. Now we could put it all together. Bam. And of course, if you want to factor this part out, you're going to get the same thing that we bolded up here. But I'm too lazy to do this. And so guys, this is how you do it. Just like that. So follow this step. This would, you'll get through it. Now, if you do got additional questions, of course, come see me and we could work this out. Just follow the steps on this one. And again, Algebra 1 EOC, you're going to see that there. All right? Because it's going to look something like, let me give you the weird notation here. Algebra 2 students don't have to really care for all that because it's not necessary for them as it is for Algebra 1. So, your crazy notation that you are dealing with, y'all, is something like this. B, I don't know why I'm writing B like that, B over 2, because that's the B term, and you squaring it like that. Or they're going to be like saying some stuff to you like this, which we did earlier, which this equals x plus b over 2. And that's the formation of writing what we just did with the numbers, all right? So essentially, that's all you have to do. So I may even question you on this notation about completing the square. So I want you to try this problem on your own. All right, people. So let's go ahead and get into all of this. So you got an equation of a parabola. Again, the parabola is the shape of the graph, which is the U shape of this quadratic. Write the equation in vertex form. So we call this, y'all, bothering me at this moment. Remember how we did something like this? We used this form to describe the quadratic in terms of the transformation. So remember, K goes up and down, H left and right, A stretch and compress. So we know those three things. Now, this is also called the vertex form. And we know that the vertex, given the parabola shape, is the tip of the graph. And has an xy coordinate. So let's do this, and let's complete the square, the little technique that we have learned. So here, people, you got something like x plus 2 plus 1. So again, we're going to take the b term, which is 2, divided by 2, raised to the power of 2, and you get 1. That's what we get. So I'm gonna show this completing the square method a little bit more different. Because last one I was kind of like just trying to be brief to the point. Now I'm gonna show you the details of this. So x squared plus 2x plus 1. I didn't put no square there. I just chose to just write it a bit more differently here. Plus 1 minus 1. And I did this because this is just another way of completing the square, but with just a little bit more detail than what I did previously. Because I want you to get every bit of all this. So guys, when we factor this, we know how to factor this, don't we? We get x plus 1. X plus 1. Because 1 times 1 is 1, but 1 plus 1 is also 2. But because they repeat themselves like this, you write it as x plus 1 with the power of 2. And then 1 minus 1 is just 0. So you could just say plus 0. Alright? That is essentially how you complete the square in this case and get that vertex form. Now, I'll show you another way of doing this. And it's going to be pretty much getting you straight to the point if you didn't want to do it like that. So let's erase. So in this case, you're trying to find the axis of symmetry. And to do that, the axis of symmetry is the x coordinate of the parabola. x got to be the opposite of b over 2a. So let's do it. Now also, going back to x over here, in this case, it becomes h. So you don't use this no more. It becomes h. All right. So guys, look. The opposite of 2 is negative 2, of course, over 2 divided by 1. That gives you negative 1. So that's h. To find out k, and again, h tells us that the graph moves left and right. All right, let's do k. And again, all I'm going to do is plug in everything into this. Everything's going to get plugged in right there. And again, the h is the x, k is my y. So let's talk about k. So for k, all you have to do is take this y, this h, or this negative 1, which is also the x, and plug in for every x you see. So negative 1 squared plus 2 times 1 plus, well, negative 1 plus 1. So again, I'm plugging in every value here. So let's do it. So we know that a negative 1 squared, because negative 1 times a negative 1 is positive. 2 times negative 1 is negative 2 plus 1. That gives me 0 for k. Now, we can finally go over here and plug in those values. Now, we never had an a, but we had a x or h to be negative 1. And then for k to be 0. Now we notice inside the parentheses we got two negatives, right? Here and here. Well, guess what happens? Two negatives become a positive. Ladies and gentlemen, you just wrote it in vertex form. And your vertex, if I was to ask you, okay, so with that being said, what's the vertex of this? You would say negative 1, 0. And you know this because inside the parentheses, when it's positive, it moves to the left, which makes it negative. And you could try this with decimals. All right, so we did that. All right, you guys figured that part out on your own. All right, time to solve equations. So, two solutions. When a is a whole number, for when you take the square root. When it's just 0, or when you have a negative number inside your square root. Y'all see what I'm talking about. So let's factor this. Solve by factor. As we know, 2 times 3 is 6. 2 plus 3 is 5. So x plus 2, x plus 3 equals 0. And I'm going to have two answers in this case. So x equals -3 and -2. So this is just solved by factoring. So this table really didn't matter at this moment. It didn't matter. But it will matter when you're dealing with the square root, when you have to take the square root. So when you have to take a square root to solve a quadratic, then the green table will matter, which I will be referring back to. And those zeros that I mentioned earlier are my answers for this function. And there you go. Solve for D. It's factor for us. So I want you to solve that on your own. Well, believe it or not, I gave the answer here because look, the graphs are there and they cross the x-axis. So say d to 0, d plus 5 equals 0, minus 5 minus 5, d equals minus 5, d equals 0, and that's just it. Alright, you could try that one on your own, and again, any problem that I leave out for you to do, you do it. Alright, solve the equation by quadratic formula. In this case, y'all, remember I was telling you about those radicals? So let's do it. So first step, here's a formula that's going to help you solve this quadratic equation. I'll sing the song to you. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. In this case, z equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. It gets creepier when I sing the song, but that is a fast way to remember the quadratic formula. Alright, so let's do it. So by now you should know 4 is being A, 8 is B, and 4 is C. So you just put them in places. So 8 was the B term, but we took its opposite. It is from there A squared equals all of that. And we just again putting the numbers in the correct places for each in each part of the formula. Then we went from there. I'm working from the inside the parentheses. And because, listen to me, you're always going to have a point where it's written like this because you got a plus and a minus. Because you have a plus and a minus, you're going to have a plus and a minus. Now pay attention to the square roots. So because the square root is 0, you're going to have at least one solution. And when you're dealing with the quadratic, this is called the square root. In this case, is called the discriminant. All right. Bam! 1 or -1. So again, because the square root is 0, you're going to have one answer. And when I put this in decimals, that's why I get one answer. Because the discriminant tells you several things. If it's 0, one solution, I'm going to put one solution of 0. If it's like a number bigger than 0, you get 2 solutions. But if it's a negative number, like a -1, you get imaginary, not real solutions. So remember, if the square root and the number side of the square root is greater than 0, you get 2 solutions. If it equals 0, like in this case, you get 1 solution or 0. But if it's less than 1, you get imaginary numbers. Going back to the graphs that I showed you earlier. You guys saw this one. You solve it like an equation, of course. But remember, squares, you take the square root of. Like say for example, if I was to say 5x, if I was to say 4x squared equals 16. To solve this equation, of course divide by 4, divide by 4, and you get something like x squared equals 4. But now you gotta take the square root of 4. So square root of 4, x equals 2. Just like that. And you're going to do it here, and you're going to determine, and because in this case the square root was bigger than 0, guess what? I got 2 solutions. And you will have the same situation here. Maybe, but look here. Look at the green table. That tells you everything. All right? You figured that one out? You worked that one out. You do it. You take care of it. You got it. You got this one. You got it. But please use your decimals. You got it. You could skip that one. That's not really needed to be talked about at this moment. You do this one. You do this one as well. Of course, you guys, this information comes from the previous video. So this is when you finish everything and you gotta show me what you got. So I expect you to do this too. All right, guys, that about does it for today.